Welcome to our Expert Perspectives series, where we showcase insights from leading experts in complex product, systems, and software development. Covering industries from medical devices to aerospace and defense, we feature thought leaders who are shaping the future in their fields. I'm Kenzie, your host, and today I'm excited to welcome Dr. Hasan Ibne Akram, an entrepreneur, computer scientist, book author, and CEO of engineering service company Matrix, based in Munich, Germany. With more than 17 years of experience in the automotive industry and working for two of the major German automotive OEMs, Dr. Hasan Ibne Akram brings a wealth of knowledge to this conversation. Today, we're excited to showcase a discussion between Matt Mickel, Jama Software's Director of Automotive Solutions, and Dr. Hasan Ibne Akram on integrating safety of intended functionality, also known as SOTIF, into the automotive requirements engineering process. Without further ado, I'd like to welcome Dr. Hasan Ibne Akram and Matt Mickel.
Great. Thanks everyone for joining today. My name is Matt Mickel, and I am the Director of Solutions at Jama Software. I am joined here today by Dr. Hasan Ibne Akram from Matrix, who is an expert on SOTIF, among other safety standards in the automotive industry. Thanks for joining us today and answering some questions around integrating SOTIF into the engineering process. We really appreciate having you. Maybe we could start with a small introduction from yourself on your background with SOTIF and other industry standards for safety in automotive.
Absolutely. Thank you so much, Matt, for having me here. It's amazing that we're having this conversation because this is very relevant today. So my background in automotive has started way back in 2005. So I was still a student, but I really wanted to go for a startup. And back then, I landed a project with Continental. It was a braking system calculation project, and that's how I got into automotive. And kept doing automotive stuff ever since. And then when I started my safety journey, I actually had no clue. So the first encounter to safety was a long time ago when I was actually working at a Bavarian OEM as an external consultant. I was more responsible for the software. And during the lunch break, the functional safety colleague of that OEM, and in German, we call it FUSI, or Funktionelle Sicherheit. So we used to call it FUSI. So I asked him, what is FUSI, the thing that you're doing all the time? What is it about? And quite condescendingly, he said, we assume that whatever you guys are doing over there, every line of code, everything that you will do will go wrong. That was kind of like a light bulb moment for me. Wow, that's interesting. What happens when everything goes wrong? What do we do? That was really my genesis of the functional safety journey. And SOTIF didn't exist back then. Was doing ISO 26262. I was during my PhD, I was specialized in automotive cybersecurity. So cybersecurity and functional safety, I really wanted to bring them together. And then we realized, the automotive industry realized that, hey, there is something missing. Because with traditional safety, the definition of traditional safety is all about malfunction. If something goes wrong, when we're doing security, it's beyond malfunction. It's all about attack now. Now comes autonomous vehicle, kind of like ADAS features, active distance control, automated emergency brake, active cruise control, and different levels of autonomous autonomy, level 1, level 2. The definitions came much later, but the idea of SOTIF was, hey, there's something inherently required. There's something required, something missing, inherently missing in the current standard, because there can be hazards beyond malfunction. Mm-hmm. It's all about intention. And this is where SOTIF kind of was created, that we will talk about safety of the intended functionality. And my involvement, like you wanted to ask, my involvement with all these standards, I was following these standards before, from the very ideas, because the community is very close community. All the safety people, like in my podcast, I had Hans Leo Ross, I had people like who are the Huntsley Ross even showed the birth certificate of ISO 26262 because he literally wrote the first lines and everything of ISO 26262. And I was privileged to be around these people who are actually shaping the shaping the future of these standards and how the engineering work will be done in the autonomous vehicle sphere and safety will be defined. So, yeah.
Wow. Sounds like it was an exciting time. You mentioned that there was a gap missing for functional safety and that SOTIF helped to fill that gap. Maybe you could describe some of the key differences between the standards?
Absolutely. So the key difference is like I said, there was a gap. The gap was pretty evident. We're talking about malfunction, right?
Mhm.
If there is a fault, that fault will lead to a hazard. That's ISO 260. That's traditional for functional safety. Traditional functional safety. Now, what happens if there is nothing wrong in the vehicle, no malfunction, and we still have a hazard? So let me give you a metaphor. Imagine that you have a knife and you bought the knife. Your intention is to chop vegetables. So it's a very sharp knife. The functionality is great. You're chopping the vegetable. There is no malfunction. You're chopping the vegetable. Now, by mistake, unintentionally, you cut your finger with it. It's a hazard. Now, there is no malfunction still in the knife. The knife is 100% functional. It's your intention that was to chop vegetables, but somehow unintentionally you cut your finger. And that's where the safety of the intended functionality came in. The famous example of such hazard is this, high-profile Tesla incidents that happened, I don't know, 5, 6 years ago, where in a junction, because of the lighting condition, Tesla's ADAS system could not recognize a truck that was passing the junction, and the driver happened to be he was watching Harry Potter, and he didn't pay attention, and this was a fatal. I mean, the driver died. This was such a fatal accident. So this was, and there was nothing wrong in Tesla's ADAS functionality. It's just that this certain condition, there was no malfunction. This certain condition was not trained, and the ADAS system was not able to detect under certain lighting condition. And that was the reason. But when we started with this, it turned out vastly complex. The whole sphere of SOTIF, when you're talking about the environment, I've just given you one example. So the environment is theoretically infinite. There can be infinite situations. And there can be situations that we don't know about. And the fact of the matter is, we don't know what we don't know. When you know something, you can take measure. That's traditional ISO 26262. Now we have this unknown unknown. You don't even know what you don't know. So that makes it extremely challenging. And that's why, the whole process of autonomous vehicle and development is going to be a continuous development process. We'll have to continuously learn and incorporate safety and all those.
Okay, so really a strong focus on limitations and unforeseen circumstances rather than on faults. Overall, how do you see that safety requirements can address these types of system limitations and edge cases?
Yeah, so safety requirements, if you define safety requirements, you have to, there are two ways to define safety requirements. So first, again, we're coming from traditional safety. You have, you do your HARA, you think about your hazards, what can happen, and you have a safety requirement for those. And you have traditional tools like doors. I guess your company Jama has an amazing tool. We can talk a little bit about that. So you usually manage your requirements in certain tools, and that's you need a tool. Requirements are complex, and I'm going to come into the complexity. You need a tool, no matter what that tool is. And then you go and working on deriving the requirement of vehicle level to the system level to software, hardware, mechanics level, and all the way down to the codes or the electronics, all the way from vehicle down there. So you need a traceability. Again, tooling is very important because these things need to be managed. Now, to touch base your question, I'm going to go back to the requirements one more time. Now, see, the traditional requirements coming out of the hub, and they're kind of set. They're set, and you verify all those requirements on the right side of the B model. And if you're familiar with the B model in automotive, we often talk about the B model. The left side is the development, all the way from requirement all the way down to the code, and the right side is the verification, validation. So you test all those. So it's pretty easy. You have requirements. For your requirements, you cover with test cases, and it's green. All the requirements are green. You're done. Here comes a situation. You can't have everything defined in your traditional way of requirement writing because, again, like I said, the environment, the operational environment that you're talking about is somehow infinite. So you have to come up with scenario-based test cases and scenario-based requirements, which are actually beyond the functional aspect of it, and a lot of edge cases. And when people talk about edge cases in ADAS, they often bring the trolley paradox. And I mean, this is from MIT's Moral Machine project. This is a very interesting academic problem to think about, but I don't want to talk about the trolley problem because I think it's overrated. How many times have you in your life had a situation where you have to either kill a grandma or a child or yourself? I mean, rarely, right? It's an extreme edge, extreme edge case we're talking about. But there are good corner cases that we definitely have to also put in here, and this is where scenario-based requirement engineering comes. And like I said, the environment is infinite, right? How do you engineer an infinite environment? So there is this concept called operational design domain. This is ODD. This is where you somehow shrink the context of the requirement. Mercedes, they did a great job when they're the first official level 3. They released the first official level 3 in Autobahn, for the German Autobahn. You could there were like several conditions in their operational design domain. One, there shouldn't be any opposite traffic. You should be driving less than 60 kilometers an hour. Later on, they upgraded to 120. And you have to be in Autobahn. These are the 3 conditions. So they reduced the infinite nature. Even within that, there is like almost infinite scenarios that you must understand, but they reduce the operational design. That makes life easier to engineer such a safety system.
Okay, so it's important to take the boundaries of the overall domain and then shrink them in order to test more effectively and to build requirements that are more finite.
The question is the safety of AI, right? AI inherently is probabilistic. It's a probabilistic model. And when our amazing machine learning colleagues are really excited about 98% accuracy, we safety people would say, this is not safe. 98% accuracy is great in terms of machine learning, but we want to have a deterministic model, not a probabilistic model. So now you have to, the question is now, the $1 million question here in terms of safety is now, am I in my operational design domain? When I'm within my operational design domain, I give AI level 3 full charge. You're even allowed to read a book. Mercedes is the first company, official level 3, and they will pay for it if something happens within the operational design domain. Now, when I'm outside of the operational design domain, this is the part where we cannot rely on AI. We need to have a very, very robust safety system so that this transition is tracked. And these are all, I mean, coming back to your question with the requirements, these are all requirements that goes beyond traditional requirement engineering. This is where scenario-based engineering. So this is getting more and more complex, and you have a need of new tools or new features in the traditional tools.
Is this something that you see organizations are currently having challenge with implementing successfully?
Great question. So there are a lot of challenges. There are successful projects, but there are a lot of challenges because without those we couldn't have cars in the street, right? So we do need to go through this kind of test phases where we have scenario-based test cases. So the challenges are first of all, SOTIF did a great job. First of all, coming up with something. It's better than nothing. We can define the hazards in the context of the ODD and what can happen, and from those we can define test cases. So a lot of things are covered with testing. So testing is really the key. And for this testing, you come up with scenario-based testing. So beyond your traditional requirement, and now you come up with scenario-based requirements as well. The typical challenge is, the first and foremost challenge is the unknown. That's one challenge. The second is, I could say there was a time there was lack of tooling. This was the first time people were doing this. The standard came up. It came much later than ISO 26262. ISO 26262 is a very mature standard by now. ISO 21448, which is SOTIF, and ISO 21434, which is the cybersecurity standard, which these two standards are not yet matured. Yeah, this is like lack of tooling. There are tools coming up. We're experimenting iteratively. Tools and all those landscape are getting better and better. So there are challenges. So lack of tooling was one of the challenges. Then, expertise, lack of expertise. When a standard comes first, you need to find out people who really have experience in the safety system and also understand ADAS. And the other challenge that I have seen is this is a challenge that I would say this is everywhere, a harmonization between safety, SOTIF, and cybersecurity. These three pieces of the puzzle, they have to work hand in hand. That's very important that they work hand in hand. There have to be communication interfaces. There should be iterations also. However, traditionally, we know automotive industry kind of works in silos. Like I've seen in big corporations, one department use different terminology than another. They're the same company, in certain cases. So on that aspect, these are the primary challenges I've seen. Yeah.
Got it. So a lot of specialization for different aspects of safety. And as we've also seen, even different vernacular and processes within disparate standards. Though I know there's a lot of effort by consortiums to try and bring those standards together. We have a lot of customers who are asking about ISO 26262 and 21434, however, not so often about SOTIF. From your experience, are there many organizations utilizing the principles of SOTIF? And if you are working with a new organization who doesn't yet think about these principles and wants to get started with this, at what point do you recommend that they actually do get started with it?
Great question. Great question. So your observation is correct, and it's supposed to be like this. ISO 26262 and ISO 21444 is asked much more frequently because they're applicable pretty much everywhere. Even if you're making a steering ECU, you're connected with via LIN, CAN. You got to be safe. You got to be secure. If you're talking about a seat heating ECU, you have to be safe, you have to be secure. Malfunction shouldn't happen, and you should have to protect yourself from the attacks. The applicability of SOTIF, however, is related to ADAS and related, camera and so the applicability is a subset of the entire vehicle sphere. The vehicle one behind one vehicle, if you count tier one, tier two, and tier three, there are usually 3,000 companies involved, 3,000 suppliers. It's a complex supply chain. And among all those suppliers, even tier three will have to go through ISO 26262, 2144 compliance up to a certain extent.
Mm-hmm.
They're all applicable, but SOTIF would be, the ADAS related functionalities mainly. That's why this is the case.
Okay, so and if you are speaking with an organization that does want to get started with SOTIF, at what point in their life cycle do you actually recommend that they get started with implementing the process?
Great question. So let's be brutally honest here. In no time in the history I've seen, forget about my career, even if you look back in history, no company have ever taken a standard unless they had to. This is like you have to enforce somehow, or they see, okay, some law is coming up. The UNECE regulation was the catalyst for ISO 2144. So the moment the company realizes that they have to comply with it, meaning that they have to comply with it. Now the question is that this is where your question is amazing. The question is when. Mm-hmm. The answer always is as early as possible, right from the beginning, because the more you delay, the more it is going to cost you. Here, this is the right answer, but the reality is it almost never happens from day one. It always is. There's a question of budget. There's a question of, bureaucracy. There's a question of many other things. So, in certain ISO, there was things are getting better in terms of ISO 26262. But let's say even 5 years ago, it was not as mature as today. And we used to hear the wishes from our clients that we build something and then we'll build ISO 26262 on top. It doesn't work like that. It doesn't work like that. I mean, the expertise of ISO 26262 now has been almost commoditized, and we don't hear this kind of things anymore as often as it used to be. But in SOTIF, it's the same. You have to do the HARA, the SOTIF HARA and the HARA at the same time, and you have to take these things in consideration. Otherwise, you will have problems.